let's get down to it. So there with us here. What you can see is that we're in our office here in Perth, Western Australia, and we're here to talk about the Wattpilot, which you can just see over the shoulder. And we start off here with why is EV charging an important part of your business future? As probably solar installers and electricians, it's a pretty good question of what's next and what's happening. So we know that out in the Australian and New Zealand market, we're seeing more and more electric vehicles on the road, but just how many are actually out there is a good question. You can see we're actually firing up quite a lot of vehicles here, and there's actually a reason we're doing that. And if you could have a guess at how many cars in your mind there is up there, there's actually 240 vehicles in this one screen. So the relevance to that number is that in 2023, we delivered 240 cars per day on average, every day Christmas, Sunday, Saturday. So as an average, on 365 days, that's what we were delivering. That is interesting because it's kind of like it's more than the daily solar installations that we were doing in 2009. 2009, for those that have been in this industry long enough, will remember it was really the beginning of the solar boom. So 2010, 11, it really cranked up. So in 2009, we were only actually installing 172 solar arrays a day. This here is the beginning of the EV charging boom, and that was 2023. We're in 2024, and it's really running hot. So what's the relevance and what do we have to look at with that? They all need access to super reliable EV charging. And in my mind, conveniently enough, the Fronius Wattpilot is the most reliable EV charger for our clients to have. And why is that? And what comes with it? We're about to cover. So our little Wattpilot here, okay, it comes in 16 amp outputs, and we talk amps because the Wattpilot 11 is 11 kilowatts, 16 amps, three-phase. Okay, it's 3.6 kilowatts on single phase. That's 16 amps there. We actually issue it as a Wattpilot 22, which is a 32 amp. So that can deliver 22 kilowatts three-phase and 7.2 kilowatt on single phase. So whether you have a three-phase or single-phase site, you need to really think about it. So just put a 22 on site and you'll be covered in all applications. All models have key features such as an ability to take advantage of time of use tariffs, phase shifting to move from single-phase to three-phase and back to single-phase on the fly, really handy in the Solar Soak Eco mode. RFID tags. This is, in my mind, should be a pretty much standard now. It was one of the initial features, but we're seeing some people drop them off. Eco and Next Trip. Eco is the Solar Soak that we refer to. And all models are available in our portable edition, which we just collectively call the Go model. If you have a camera on your phone ready, consider just scanning some of these QR codes that will pop around. If you scan this one, it will download straight to your phone the Wattpilot brochure, and that will download and you can review that later. We can also send these after the fact if you wish. In the Wattpilot Go, it's portable. So as you can see in the front of my car, it comes along for the ride. I can generally sniff out an outlet, which is a 32 amp 5-pin outlet. And in my local parking garage that I park at regularly, they offer free access to these. RFID plug still, push button, really nice to have a manual push button for some quick manual selections, which we can set up later on. Just also Wi-Fi is on board to connect to Wi-Fi, but also to connect point to point. Wattpilot Home, this is more of a permanent install in the traditional sense that people like. Again, very similar to the Wattpilot Go, Wi-Fi, RFID, push button with the addition of an 1800mm cable. It's top entry, so it's nice and easy to go straight up to the roof through a conduit and into a termination box if you wanted to. Okay, what are our variants? Just to cover over this again. Wattpilot 11 is a 16 amp, 3.6 kilowatts on single phase, 11 kilowatts on built 3-phase, 5-core cable, neutral conductor, 6 to 16 amp, 1-phase or 3-phase. The 22 home, 7.3, 22 kilowatts, and so go from 6 amps to 32 amps. 6 amp is generally the standard that electric vehicles will start charging at. So on single phase, basically 1.4 kilowatts of power is its first initial start. And the Wattpilot Go, exact same as the 22 home, but it's portable. Okay. And the tail on the Go is 300 mil, so we're not having to leave this on the ground. It will actually hold within the power outlet. Okay, but what is in the little box here? So first and foremost, we have the mounting bracket, and I'll just show you that the mounting bracket simply installed and it just drops down. That's how easy it is to make that work. We also have the Wattpilot itself. We have a anti-theft bracket. It's like a little collar around the cable. You can put a padlock through it if you wanted to. A question that does come up is, Shane, if I'm using the Wattpilot in a public setting, it's plugged into the 3-phase outlet, I've got my cable, goes into the car, what prevents someone from stealing it? The fact is that the car will hold on to the cable. There's a locking mechanism inside this charger, and that will hold that cable. So if they undid it from the outlet in the wall, they can't take it because it's all locked to the car. And if they manage to get it off at that point, they really wanted it. So not much would be able to stop that. A reset RFID card. So it's just one of these with the QR code. If I was to tap on the RFID, it would reset it to factory settings. You can reconnect to Wi-Fi, change everything. It says in both English and Austrian for you, do not lose it. This is really, really important if you ever wanted to reset it. And as of a recent firmware update, we can assist without one of these, but do not lose it. Get the client to put it somewhere safe. And you'll get a ID chip, RFID fob in there as well. And there'll be the quick start guide. So if you wanted a quick start guide, we have the QR code here as well for you to get that. I'll give you a couple of seconds there. Again, any of these get missed out, feel free to email us and we'll send you the bundles.
Phase shift.
So some options to consider when offering the Wattpilot to your client base. Do they need a Type 2 cable, or do they have one already? A lot of public AC chargers are not tethered, and that is mainly because they get damaged. So I carry around a Type 2 to Type 2 cable for the vehicle. You can get a Type 2 to Type 1 cable if they've got the old Nissan Leaf. But these are also offered by our sales partners in different amperages. So you can actually get these in 16 amp only. So you might have a 22 kilowatt Wattpilot, but you might have a 16 amp cable, and you call us and go, why is it only charging at 16 amps? And we'll explain that in the next couple of slides.
Phase shift.
You can buy extra RFID tags. I have used my EV or my ChargeBox card and programmed it on there rather than carrying around another fob. Old hotel keys work really well also. And you can buy extra mounting brackets for your clients. In the case of a Wattpilot Go, they might have an outlet at home and they might have one at their office as well, and they want a bracket there for it. So they're available from our partners also. Now, as we sort of said before, the Wattpilot Go 22, what if I've got a single phase site and I want 32 amps? It's a 3-pin outlet. Have been advised that a lot of people are using the 5-pin 3-phase outlet and wiring it up as single phase. That's something you need to look into around the legalities of it. But generally, if you had a 32 amp single phase outlet, it's a 3-pin, you can get your hands on a plug and a socket, and now you've got an adapter, and that's my one. So if I find a 32 amp single phase outlet, that's how I work with it. I've also got adapters that will allow me to go down to a 15 amp and a 10 amp and a 20 amp 3-phase plug. What you need to do is make sure that you set the maximum load in the Wattpilot to the maximum setting on the site for your provisions. So couple of EV charging basics. You may come across this when selling the Wattpilot. Is my clients told me they have a Type 1 AC connection. Maximum power on this is 7.4 kilowatts that this plug can carry. Very mainly used on the first generation of Nissan Leaf. So you may not see too many of them, but the Nissan Leaf can only charge at 3.6 kilowatts single phase. So if it's a permanent install, you could use the Wattpilot 11 on that. CCS2, now this is the fast DC charging. The two little prongs here are your DC, and it uses this top part here for the comms to come through. 3 bays, right now we're getting up to 350 kilowatts. It's quite interesting watching a car charge that fast. Generally the Porsche and so on, because they need 800 volts. So 800 volt DC and pulling 350 kilowatts, a lot of power through it. The other DC charger that was early, again with the Nissan Leaf and Mitsubishi plug-in hybrids, is the CHAdeMO. That's a weird way to say it, but you could only do up to 175 kilowatts, and I never really saw a charger beyond 50 kilowatts with CHAdeMO in Australia. What the Wattpilot uses is Type 2 AC, and you'll notice that the Type 2 AC is very similar to the comms part of the CCS2. These are the two standards that we're really going to see roll on. Now, Type 2 AC can do 1, 2, or 3 phase. I haven't seen a 2-phase charger for a very long time, if ever. It can do 400 volt, 32 amps, 63 amps, which means 22 to 43. Again, we're really only seeing 22 kilowatts. It's very hard to find a car whose AC onboard charger will charge at any more than 22 kilowatts. Sorry, any more than 11 kilowatts is the most popular. Give me. So that's the whole range right there. So many standards have appeared, but what we need to really look at is what happens on the Type 2 and what all the contacts do. So obviously we can see L1, 2, and 3 are clearly our 3 phases. L1 will be for your single phase sites, and when you're wiring up the Wattpilot, you'll see that. You have your protective earth, your neutral, and we have our proximity pilot and our control pilot. Now, our proximity pilot and control pilot, this is the magic communication that's going on between these two. So your control pilot will tell us the vehicle status. Okay, am I able to take charge? Do I need charge? Sending the start and stop command. So it's actually the vehicle that's saying, hey, I need to stop, or maybe the charger's saying, hey, you need to stop charging. So it's a little bit of communication around there. And it communicates the max current load that can be applied from the Wattpilot to the onboard charger. So for example, if our Wattpilots get very, very hot, we could actually tell the car, hey, you need to reduce the rate on which you're pulling load so that we can cool down. Our derating algo is pretty good. A lot of the derating used to be like, let's derate a lot so we can cool, then increase, then cool, then increase. We will sort of derate at a much earlier stage and keep a higher rate longer term. Your proximity pilot, this is about your cable capacity. What can that cable between the Wattpilot and the vehicle carry, whether it's 16 or 32 amps, and it's using a resistance between 100 to 1500 ohms. EVSE charging standards. So it's a pretty robust charging protocol, and communication is done by a series of voltage driver circuits, which are detected once physical connections are made between the EV and EVSE. It's pretty basic. One thing I will point out, it does not facilitate information like state of charge. So you'll never know how much charge is in the car when doing this. So if a client says, hey, how do I know how much charge is in my car? Car needs to tell them. If we are DC charging with a big DC charger, we can actually get that information out and they'll see it on the charging app. This is how much charge, this is how long we've got to go. But something like the Tesla and so on, their app would be able to tell you. Now, working in Queensland limiting factors for the charging capacity, and we have some of this in Western Australia on single phase as well. and how do we get through that? Let me come back. So effective of 21st of February this year, general equipment limits in single phase at 20 amp. Essentially, if you wanted to go over that up to 35 amps, then there would need to be a device management, which is something like Catch Power, which integrates with the Wattpilot, would be a good choice to be using that. And obviously controlled tariff via a network device as well.
Phase
So
shift.
limiting factors for the charging capacity, we sort of touched on these earlier. It is the supply that we can actually deliver, and this includes things such as what are my loads, is the solar giving me more generation that I can take advantage of. Our Wattpilot, maybe you bought the Wattpilot 11 instead of the 22, and that's limiting them down to 16 amps on the single phase. The cable, the Type 2 cable, which we mentioned, you can get them at a small capacity and a high capacity. It's about $30 difference. You always buy the higher capacity one. And the onboard charger of the vehicle. So just a little heads up, BYD, we have one of them in our household. It is only a single phase onboard charger. So whether you have a 3-phase or a single phase site, it will only charge on L1 and it can charge at 32 amps. So if you've got a 3-phase site and you're charging at 32 amps and you've got no other generation from solar, you could be at risk. So using our 3-phase smart meter and the Fronius infrastructure and the inverter, we can actually throttle down the Wattpilot to make sure we protect your mains from breaking there. So I'd set that at 30 amps, for example. Hope that kind of makes sense. We're breezing through this a bit, just conscious of time. So charging with the Wattpilot. So as you can see here, we've got some illuminated lights that are going on, and 1, 2, 3, 4, 5, 6, 7, 8, 9, with 9 amps of load here, but you can set them 10, 15, 16, 24, 32. One solid press each time will cycle from level 1, 2, 3, and 4. Why would we do this? When you go to a lot of sites, they may tell you at this site, like the garage I park at, do not charge at more than 15 amps. It's the max we can take. Someone will come along, they'll charge at 32 amp single phase, and it tricks the site. So it seems that some people not reading the instructions for that site, you can go beyond it. So that's one important factor to be considering. The other is the scheduler. So we can select times to charge or not to charge. That is a question, I suppose. But so we can have start and end charging times. This image shows that the scheduler is actually disabled. So as soon as you plug the car in, it's going to charge. And you can also see that we have weekdays, Saturday, Sunday, because some of those time of uses will talk to you about that. And you have 2 zones able to be set per mode. So on a weekday, we can have a start and end time and a start and end time, two modes there. And that's for Saturday and Sunday as well. To put it in practice, me being in WA, I've used a lot of my own personal real life examples here. So I'm on the Synergy Midday Saver with an EV add-on. 9 a.m. to 3 p.m, it's 8 cents a kilowatt hour. It's a great time to be charging. 3 p.m. to 9 p.m, 55 cents a kilowatt hour. Not a good time to be charging. 9 p.m. to 11 p.m, it's 22 cents. And 11 p.m. to 6 a.m, it's 18 cents. So essentially, 9 a.m. to 3 p.m. is one time that I want to be able to charge. 11 p.m. to 6 a.m. is my second choice to be able to charge. And that's what you can look at here. So 9 a.m. to 3 p.m, we can start charging. It will stop charging at 3 p.m, and then it will start again at 11 p.m, go all the way through to 6 a.m, should I wish it to go that way. To achieve PV surplus modes, we do need our, solar soak, eco mode as we call it. We want to charge exclusively without excess power. So it's in the afternoon after that 3 p.m. and we want to use that. Need the reference point. So there's a couple of ways of doing that. I'll talk about the cloud method. So we are integrated with Charge HQ, which is a cloud product. And essentially with our Wattpilot Online, it talks to Charge HQ. Our inverter talks to Charge HQ, or it could be a third-party inverter that talks to Charge HQ. and it will come up to the cloud and tell us how much surplus power we got. A couple of issues with that: there is latency, there is time to respond, and it is a monthly cost. It used to be, for us who used it initially, it was free, but they've added the cost to that now. So what can happen is the inverter might say, I have 2 kilowatts available, goes up, tells Charge HQ 2 kilowatts are available, tells the Wattpilot, hey, you've got 2 kilowatts. That latency plus the update time, a lot of clouds could come in or loads could change and you could end up buying more power. We could be exporting power. Doing everything locally is a preferred method. So you can have a Fronius inverter, you can have a data manager box, which is just like brains of our inverter if you haven't got a Fronius. You can have a smart meter, you can use our IP smart meter, a new update allowed you just to put a Fronius smart meter in, and the CT clamps. It just looks for power going to the grid. Any power comes in from the grid, it's going to reduce its load to accommodate that. Catch power is also integrated with Wattpilot, so you can use on single phase sites catch power and it just communicates with us that way. Okay, so surplus charging, how does it work? And so we have eco mode and next trip mode that we would talk about. It's in that area. Look to devise the threshold of starting for going from single phase to 3-phase, and that switching on the fly is possible. I'm going to say that there's probably 1 or 2 other chargers I know that can go from 1-phase to 3-phase, but the time it takes them is so long that the export limiting can reset itself down. So we will increase in 1 amp increments, so each amp up and down. So for 230 watt, 230 watts per amp on single phase, 690 watts per amp on 3-phase. So here's a little graph, and I've got an illustration after this, might make it a bit clearer. As we said before, electric cars need 6 amps to start charging. So if we have 1.38 kilowatts spare going to the grid, great, we can start charging at 6 amps. Sorry, we can start charging at 6 amps there. The charger will then apply another amp, and another amp, and another amp, and another amp. I notice that these are 2 amp increments. And if it goes to, say, for example, in this case, 3.68 kilowatts, and it sees some power going from the grid, it's going to back off to 15 amps. Clouds may come across, and that's how it shifts up and down. So as we climb up here, when we get into that 6 amp 3-phase point, so once we reach 4.14 kilowatts to 7.3, it's at that time we can shift to 3-phase if it's a 3-phase site. Of course, we want to do that to be better at balancing loads. So as we get to this sort of 18 amp area, we can switch over to 6 amps 3-phase, and then we increase by our amps on the 3-phase. So where this is really important, and we have this in Western Australia, if you have a solar inverter over 5 kilowatts, you must export limit to 1.5. So if I plug the charger in, or I plugged in a charger and said, I want to be able to charge at 11 kilowatts on 3-phase, it will never start because we'll never have 1.38, we'll never have 4.14 kilowatts to start charging. So what we would do, we'd start on the 1.38 and we would move up until we phase shift. So looking at an illustration, I've built this up here. You should be able to see it. It's something we're familiar with. We're producing 2.7 kilowatts over here, and our load is 1.2. This exercise, I kept the load at 1.2 kilowatts, and we're exporting that 1.5 kilowatts because we're limited to 1.5 kilowatts on the export. So what we see here, we've got this graph on the right. We have started charging at 6 amps, 1.38 kilowatts. You can see our power has increased. Our load has increased by that 1.38 kilowatts, and we're now only exporting 0.2 kilowatts. So at this time, that the inverter will ramp up to meet that 1.5 kilowatts of export. And as it does, we're going to grab it. With that extra amp that we're putting there, we're making 3.2, we're only exporting 1.6. So as we keep going, you'll notice that our production goes up. We're not exporting because we're grabbing it as it creeps up. Now, when we've sort of hit into this 4.14 kilowatts, we're at a point that are in the phase shift zone, as we call it. So we can shift to 3-phase if we want to. It is customizable at when you actually want to ship this. I would generally wait till I get to about 5.52 kilowatts to ship those loads, jumping up and down. But we can go all the way to 7.3 kilowatts and be either in 3-phase or single phase. And it's after this that, if we want to go any more than 7.3 kilowatts, we've got to be in 3-phase. So now we're only in 3-phase. What you're looking at here is 11 kilowatts of load. This isn't unfamiliar with sort of 15 kilowatts of inverter and sunshine. We're exporting 1.5 kilowatts of that 13.7 generation, but we are putting that 11 kilowatts of power into that car. If you've got a Renault or a Model S Tesla, you would actually be able to jump up even higher again. Okay. So I hope that makes sense, and I'm happy to go back to it, or you can contact me. We can discuss it more. To see what this looks like in an example of a house with a Fronius inverter, batteries, and so on, everything there, you can see that at midnight, we're discharging our batteries here with our loads. The sun has popped up, we've recovered a bit of our batteries, the load's dropped off, and the car is now charging because it's in purple. There's the 1.5 kilowatt export limit that has allowed us to continue our generation, which is the yellow. As we keep going up, we are in the phase shift zone, so you can see what kind of generation we've got to be in. And we've actually left the premises here with the vehicle, and they've come back, they've plugged it in at some point, and there's just been a small amount of excess power, which has grabbed it here. So something else to consider with an EV charger is I'm wanting to leave tomorrow morning, and I want to make sure I've got X amount of kilometers of charge in my vehicle by that time. We can actually say, how many we're going to need and when it needs to be ready by. So first thing you've got to know is, what is the amount of energy I need to do a kilometer? So here's an example. We can see on this site, on this vehicle, they've used 95 watt hours per kilometer, which is a 9.5 kilowatt hours per 100 Ks. It was done on a 27.5 kilometer trip, so it's pretty fair to get a number out of that. And what we then do is we go into the next trip mode on the app of the Wattpilot. We want 100 kilometers in the battery, and I want you to be finished by 6 a.m. I've also updated that the total kilowatt hours per 100 kilometers is 11 kilowatt hours. I want to make sure I can run aircon, heaters, deal with the wind or hills, etc. So the fact is 11 kilowatt hours per 100 kilometers, be finished by 6 o'clock, and I want 100 kilometers to go in there. Eco mode after next trip mode is set. So say, for example, I got stuck on a phone call or I can't leave. I've added that 100 kilometers in there, but if there is surplus solar, give it to me as well. I'll take that. So what does next trip mode look like? The car has started charging. It's actually finished early. It's a little feature sometimes that I make sure everything's going good. So the house has used a lot of power. It's used the battery to charge as well. There's household loads. It's met the 100 kilometer requirement. Someone's woken up. They've been getting ready, toasters, irons, whatever, and they've unplugged the car and they've taken off. They've also been a gentleman, plugged in the car for the other person. As the day's gone on, sun's popped up. Other people, we've got some batteries recharging, we've got some loads coming in, the rest of the family's woken up, and the sun, we now have enough power to start charging the EV. So very intelligent way of making sure everyone's covered and you've got all bases sorted. Now you may have a Fronius ecosystem, batteries, own pilot, hot water, and an EV charger. Generally, a family would be pretty annoyed if the hot water isn't exactly hot because we chose to charge the car or the battery. So what are we going to do here? And it's basically called sector coupling. So in this instance, we have sector 1, which we're calling the battery and the hot water. So first thing we want to do is make sure we have our battery, sector 1.1. Once it gets to 70%, we will then start heating the water. We want that 1.2 to be 40 degrees Celsius. Once that's 40 degrees Celsius, we will then say any excess energy can go to the electric vehicle. This can be set up however you want, and might be some trials. The client can generally figure this out because it is available inside the app. So you can go into your priorities, battery 1, own pilot 2, load management 3. We can go in here, we can say that the battery threshold is 70% and the water is 40 degrees Celsius. And after that, we're moving on to the electric vehicle as the illustration showed. So what do we do on a zero export site if we want to charge with excess solar? The fact is, if it's a zero export site, there is no surplus solar. So this could be a commercial site where they've said zero export. So how do we actually do this? You'll actually go into your PV surplus. You'll say your starting power level, 1.4 kilowatts, and you'll activate zero feed-in and run on the default. So what will actually happen here is we'll sit there and go, we should be having excess solar around about now. What we will do is we will fire off 1.4 kilowatts of load into the system and we'll wait. So the Wattpilot goes 1.4 kilowatts, please. It will see some power come from the grid as the inverter ramps up. As the inverter is ramping up, it offsets the grid. We're now back to zero export, and the Wattpilot intelligently would say, well, I'm charging and I'm not pulling anything from the grid. Let's give it another amp. And we start that whole ramping up and switch into 3-phase. And then as we see some power come back in from the grid, we will back off by an amp. Could be a cloud, could be an increased load on site, but it will actually work all around that methodology. So very, very cool way to get your car charged from solar when there's a zero export site. Dynamic load balancing, we sort of touched on this earlier. You can distribute it between, so the power of the site can be distributed between multiple Wattpilots. You do need a smart meter on there in the Fronius inverter. So this can use extra, you might have a limit of how much power is available to the site, and you might sort of use the solar, use the grid in conjunction, but as the solar goes down, we want to actually reduce the load from the Wattpilots. Rather than using this as a solar soak, this is just get my car charged, but make sure we don't trip the mains. So, as we get up to that 63 amps on a single phase or 32 amps on a 3-phase, start dropping things down, dropping those loads down. RFID authentication. So coming back to this as before, personalized access using an RFID card or chip. You can actually assign a power level to it. So if it's at a workplace, someone you only want to give 5 kilowatts to, or the boss needs the full 32 amps, you can do that as per the card. You can have up to 10 RFID cards per Wattpilot. Pretty easy to do with some, to use it for simplified billing. You could turn to the staff, says how many kilowatt hours you've used, and you could charge them, I suppose, if you're that way inclined. You can data dump it into a CSV file, but in the app, it will show just like this. So this is our house one here. You have 265 kilowatts have gone to the Tesla on this charger and 232 to the BYD. The fact is it needs authenticating. We've actually got, I don't know how well you can see my camera, but what you can see is it's blue lights here on the Wattpilot with the white flashing lights going around. That tells us that it needs to be authenticated. So if you approach this site and you wanted to start charging, you would simply hold this, green light, and then it's moved to pink, and they're customizable, those colors, by the way. So now it will charge and it will assign the kilowatt hours to this particular, this one goes to the BYD, and that will just accumulate, and it's live. You can look into it and see how many have actually been going to it. Communication of EV chargers. So you do not need to hardwire the Wattpilot back to a router. It is Wi-Fi. It's only on that Wi-Fi LAN. It reads the inverter and meter data via local solar API. This is all done on the Wi-Fi network at 2.4 gigahertz, not 5. The solar APIs are turned on by default in the inverters. Sometimes if homeowners been playing around a little bit with it, you might need to turn it back on. We all use OCPP 1.6 to communicate this, and it is a standard, as much as a standard can be. So Open Charge Point Protocol. And you have this QR code here. What this will do is it will download our OCPP file. This is in case you want to work with a pay-to-use partner like ChargeFox, Everty, WeVolt, and many others. Some of them are already integrated. So I use WeVolt on my one. So if we need to, we can use the app. But to be fair, we also have a standalone app for the Wattpilot, which is available both on cloud and point-to-point. So it's this is actually a big must, because point-to-point, you've got it for commissioning, visualization of what's going on, and the general operation of the Wattpilot. We can connect point-to-point. My phone's connected directly to this unit. So if you're in the parking garage and you want to control it and get into the intricacies of it all, you can just do it point-to-point, connect to the Wi-Fi access point, and it's all there. And obviously, that's another way that you would actually connect it to the Wi-Fi. Amperage, charging modes, and your time of use thresholds, thorough live overview and visualization of all your data. I think we're pretty aware of that with Solar.web. Charging modes from anywhere, should it be connected to the cloud. Those apps are obviously available on both App Store with Apple and Google Play for Android, and they can be found with a pretty quick search anyway on those various app stores. So how do things actually look integrated, and what do we get with the Solar.web? So you have to add the device to the Solar.web and delete it manually. So it is a device, just like a component, like a smart meter. Multiple Wattpilots are summed up as one. So if you've got 10 Wattpilots on a site, you'll see the total consumption of all Wattpilots. If you clicked on the bubble chart where it's the load, what you're actually using, you can see here we've got smart meters and other devices, but the Wattpilot in the garage is telling us that we're pulling 3.7 kilowatts there. And detailed values obviously can be viewed separately in your charts. And you can go into your reports as well in Solar.web and get all the unique data that's needed. We also have a very intense back end for Wattpilots, where if they're online, we can get a lot of data out of it to find out what's going on, even down to what are the temperatures of the probes, the temperatures of the PCB. All that's available to us, and that's because Wattpilots are very much like hot water. If they don't work, there's going to be some problems. So we're very, very much ready to help if there's any issues. The visualization, as per some of the previous charts, is in purple. So you can see the battery has been depleting here with the loads overnight. We've had a little bit of battery recovery, loads increased. So the battery's depleted again. Great recovery on the battery. Our own pilots kicked in. Water's hot, battery's full, and the loads are minimal. So we're now exporting to the grid. Cars come home, plugged in, and you can see how well we actually follow that load profile. Own pilots delivering a little bit more spare electricity to the actual hot water because the sector coupling tells us to. And the car's charged at this point, and we've just pushed a lot of power back into the own pilot going off into the nighttime. And we can see the battery actually depletes at that point. Nice monthly view. You can see what days you are charging. If you've got premium membership, you could click on the 12th here and you would bring up the granular data for that. You can go into your history of the Wattpilot and pull these reports. So your voltage per phase, that's going to be really important because you want to make sure that if you see that there's low voltage on the charger here, but you've not got grid low voltage on the smart meter, you can actually determine that perhaps the cabling dimension wasn't actually done correctly. Currents per phase, your power factor, device performance, Wi-Fi signal strength. This is one you need to look at. This has actually got quite a good signal strength of -50, what's that, -55 dBm. Anything that's weaker than sort of -60, 65, you might have some issues. So always try to make sure it's stronger than -55. Other chargers and types that are actually out there: fixed wiring inverter integrated. So being fixed install with the inverter, we know that the charger inverter is going to be right next to the car. Your traditional tethered fixed devices, as we can see here, that everyone's used to. And we're obviously making sure we have portable devices available as well. Very, very handy. And having a 3 amp plug as opposed to a full hardwired system, I think it's great to have the options available on what the client wants there. Okay, so we find that some car manufacturers will make their own chargers, whether they are theirs or not, and you're always going to get people who want to buy the actual car manufacturer's chargers, so they have the full ecosystem and branding. In a lot of cases, they're not doing much more than a dumb charger. Third-party chargers, a lot of features to come in. So if you're an EV charger manufacturer, you'd be looking for those unique features and bring it all together, as opposed to a car brand that might just say that's all we want. Inverter branded chargers such as ourselves, obviously we're integrating with your PV, energy management, load control, batteries. There's a lot to be had there. But one thing I'd say is make sure you understand the chargers. How do they use the PV surplus? Are they load balancing? And the scheduling, and definitely must have OCPP on board as a comms. It's like, imagine having an inverter that doesn't have Modbus. It's not going to really be a thing. So talking one point, we will see some people always put an AC isolator and some won't. Generally, there's some standards here for you to take note of. We technically don't really need to have an isolator at an EV charger because our charger isn't a charger, it's a EVSE, it's a outlet. And if we go into our next part here, a socket outlet that is switched by the insertion and withdrawal of the plug is deemed to meet the requirements of this clause. So do you put an isolator or not? It's kind of up to you. I don't like the aesthetics, but on the flip side of it, it's really nice to have something to turn it off, turn it on again. If you have a problem with the car or the charger, whatever, you can turn it on and off rather than going back to the board and switching it. Personal preference, I'll leave that decision with you and discussions with your clients. RCDs, so if you look at our technical product sheet, we have our DC integrated in, ours being integrated into the device. You've got to check your manufacturers to know what their rating is, i.e. looking out for DC leakage detection. So if it has what we're needing in here, like what we've got, then you just need a type A RCD, should be used in the switchboard. If you don't have that, then you need to go to a type B. So, if you're paying a little bit extra for a charger and you feel you're getting good value, including stuff like this, it might save on the install later on. So in summary of those little moments, best practice is to install an adjacent isolator, in our opinion, to be able to turn it off, on again, troubleshooting and so on, should that happen. You could use the circuit breaker as your main switch, and be mindful of other sources of supply when calculating the switchboard ratings. I might also state at this point that when you're doing your cable and your hardware dimensions, just allow for the thought of how hot does it get in the distribution board. If I'm using a 32 amp breaker, will it derate in the temperature and trip when it might only be pulling in 29, 28 amps of load, and obviously your cable dimensioning. So finally, this is the last slide. This particular QR code will take you to a YouTube playlist from Fronius Australia. And this is every little video you need to know on how to commission, connect, and use the Wattpilot. So feel free to scan that and download that and make sure you can go and watch it at a later time. Leave it, and thank you for coming and joining us on the webinar.